All right, so first time, last time we took with Chris, we just had a quick discussion about having a little bit of a more contrarian view on Ethereum. And the point is just to give another perspective and not necessarily. I hope it will all be constructive. So I'm Matthieu. I'll just go quickly over these. So I'm the co-founder and CTO of BlockCypher. Stay here. We've basically rebuilt the Bitcoin, or kind of the blockchain standard way done by Bitcoin in the cloud environment, so that we can scale it really well and support it really well. So we can separate things like the peer-to-peer network from the front end, from the storage, it all scale linearly, things like that. And so we have a pretty good understanding of how all of that works, how all of it can be made to scale, how data can be extracted, behavior can be added. So we expose all of that through web APIs. And then, so we have Bitcoin support, we've added Litecoin all on the same infrastructure, it's basically just parameters for us. And then just released, well actually we're releasing this week a multisig API, so that's the first time I talked about it in public. So it's the same thing, very easy way to make multisig transaction on Bitcoin, and we have webhooks, WebSockets, all of that. So quickly about me, I've been building platforms for a while in finance, in some green tech companies, and all kind of developer platforms. Sometimes hosting code, sometimes providing more like libraries type environment, application servers, things like that. And I've built the BlockCypher infrastructure, which is built in Go. So as I was saying, I'm going to play a little bit the devil's advocate. I hope it will be constructive. I don't mean to. I think Ethereum overall is a great thing. I think every altcoin, well, I guess, as far as all the altcoin goes, I think Ethereum is one of the more interesting ones because at least it tries to experiment in a lot of areas compared to altcoins that just change the hash functions and the block maturity, which is kind of all bogus. But I'll still play the devil's advocate and try to tell you what I think is so-so with this theorem. But I'll start with the good stuff. So yeah, I'll start with the good things. But that will be short because I know that you guys have been talking a lot about the good things. So I'll transition quickly to the bad things, and I'll let you judge whether it's bad or ugly. So one of the good things about Ethereum that I just mentioned about, and that I like about it, is there's a lot of experimentation going. So it's one of the cryptocurrencies that has decided to redo the most and to change the most the base of Bitcoin. If you look at all the cryptocurrencies, all the altcoins that are out there right now, they just take the Bitcoin code base, change a few parameters or change a few lines of codes. We compile it, send it, and that's it. Whereas in the case of Ethereum, pretty much everything is redone. So the base concepts are kept. There's a blockchain. There seems to be a proof of work, and there seems to be a scripting language, but all of that has been completely rebuilt. So the experimentation is good. It's also very ambitious, as I was just saying, compared to other altcoins. There's a lot of it that's been completely rebuilt. There's 2 implementations, as far as I know, plus more coming in other languages. The scope is really broad. It's basically to be able to do anything on the blockchain. So that's kind of interesting. Now I'll start switching to the bad thing. So over-ambition can be bad. And in that case, the line is kind of, it's a little blurry. And cryptocurrencies are actually difficult. Bitcoin and the Bitcoin blockchain is a big recent innovation. I believe that's going to change several things, even in day-to-day life, over the next maybe decade or two. It's going to probably take some time. And so experimentation on it is great, but shouldn't be presented as, oh, we have the magic formula, we know it's going to work. So overambition, so that's where we go into the bad and the ugly. So now, before I go too much into it, if you have, like, if I say anything wrong, right, I know Bitcoin really well. I don't know Ethereum as well. I do Bitcoin. So if I do anything blatantly wrong, just interrupt me, and I'll say, I stand corrected. And well, anyway, I stay kind of, I don't go too much into the detail, but we'll see. So overgeneralization. So well, generalization is always on this. But overgeneralization is often a problem. If you look at most systems that have been overgeneralized, they end up being useless. And I've done that mistake myself several times in several platforms I designed, so I can tell you that firsthand. When you overgeneralize something, you give up the boundaries, you give up the constraints. And constraints is what people build on. So it might sound a little abstract, but I can tell you that exactly what happens is that when you extend a domain to basically its base component and try to make it as something that you can build on top of as much as possible, it loses a lot of its usefulness. Just because you haven't constrained it, you haven't given the tool. With constraint usually comes additional usefulness. You look at things like Quest, right? Representational state transfer. It's all about constraint. You're constrained to 4 methods. That's all. Compared to things like SOAP that happened before. Look at programming languages. I'll go into that a little bit later, but Turing completeness, right? Turing completeness doesn't give you anything. There's a lot of things that are Turing complete. Lisp has everything. It's a great language, but it's still a very small community. Why? Well, because it's not been made from the start to solve a problem that was really applicable for a lot of people. Look at Ruby, Python, right? Okay, I can write a script, use the file system. It's really easy. I can see what I can do with it really quickly. That's my first point. Generalization, overgeneralization can be a problem, and you can see that in the sense that people have a very hard time projecting their imagination on it. They can't see what to do with it. And I've had that problem again in like at least a couple platforms I've designed before, where we build a platform that could do pretty much anything, but what we're supposed to do is not anything. It was a specific problem, and nobody could understand it. Then, so Bitcoin had to narrow down, right? So you can see that Bitcoin has much more original functionality than it has now. A lot of opcodes have been deactivated. You can write many different scripts in Bitcoin, but actually very few as standard. Actually now there's only 4, I think. A lot of things aren't where we'd like to do that at the beginning, like any number of signature operations per transactions, or log time replacement that would have been really useful for contracts, things like that. All have been deactivated because they're vector of attacks. And there's a reason for that, right? That the surface area may be a problem in case of attack. So Bitcoin is a little dumb now. You can say that the scripting language can be a little dumb, but it's for reasons. Right. Like, so for those who will know, that's Alan Turing. So the Turing completeness thing.
And why is Hollywood there?
Because he's been kind of pimped up, right?
Oh, okay, all right. Okay.
So the whole Turing completeness thing of that Ethereum started with, right? Okay. I mean, okay, that's fine, but it's marketing, whatever. But there's a lot of Turing complete things that are completely useless. So that's an example. And it's actually not useless. There's been application of that. But that's called cellular automated. So basically, from the top line, you just imagine it's a loop that from the top line, you have the next line. And from the next line, you have the one after. And the rules of interpolation are up there. So you can see on the first line, right, we use which rule? We use the rule that's the third one from the right. And then from the second line, we use the rules that all the way to the left, and so on and so forth. So that's Turing complete. Right, you have conditions, you have loops. It's been shown that you can do anything with that sort of very simple cellular automated thing. you can actually, it turns out, simulate randomness really, really well. And so there's a random generator algorithm that's cryptographically secure that's based on this, after enough runs and everything. But the point still remains. Pretty much anything, well, pretty much anything, that's an exaggeration. A lot of things at Turing Complete, are they interesting? Not really. So that's not really saying much. And the whole, okay, in Ethereum language we have loops, well, it doesn't, I mean, it's not rocket science. So, and then the whole continuing on the scripting and loops and Turing completeness. So that's loop unwinding. The idea is that in every compiler, pretty much every compiler that's been well optimized that you know of, there's very little loops in the final language because all the loops are unwinded. Basically, the compiler go and say, oh, okay, that code has to run 10 times. So I'll just copy the code 10 times. Why? Because it's much faster to execute. That's what Bitcoin does, right? You can have like multisig, you can have several signature operations in the same script. And my argument is that in Ethereum, anyway, almost every operation are bounded. The execution engine itself is bounded, just because you need a certain amount of Ether to run it, and then you also have Ether. My understanding, at least, is that you have Ether limits per transaction per block. So unwinding at this point is pretty much the same. So that's kind of continuing on the critic side, is that that's good Git porn. So you have nice language, you can write any kind of little scripts. You have a high-level language. There's already two languages, right? There's a lower level one and the higher level one, Serpent, I think. But there's a few hard problems that still haven't been solved. And my whole point is just to say, okay, maybe it's time to not focus on the little shiny things that I'm the same. I like the shiny little languages and things that look interesting. But there are a few hard problems that still don't seem to have been solved. So, okay, maybe I'll start with this as well. So I haven't seen any solid proof of work algorithm yet in Ethereum. There's a temporary one, and then anything I've read or looked at, it's like, oh, okay, well, for the final release, we'll have the real one that kind of uses past transactions, and rewind them, and sees the world of them, and hash them, and whatever. But still, like proof of work algorithms are not simple. You can't take anything you want and just say, oh, it's proof of work. Okay. Then the next thing is, at least again for what I've seen, the script has to be executed by everyone, right? Like when you send some money to a contract, everybody has to get that transaction, run it, validate it, and get the output of it. Everyone in the network does that. Only one person reaps the benefit of it, which is a miner. So you can write really expensive scripts, programs. They are really, well, they can have, depending on the limits again, but can have a high cost for the overall network, but you're not getting paid for it. So then you have to wonder what are the, is that point?
Well, I mean, the only people who are going to run all the scripts are full nodes, and the idea is to make the proof of work algorithm to be memory, what is the right word? To make it so that almost every full node that's running it can be a miner.
Yeah. So that's kind of what it points at, right? Because there's very little incentive to run a full node that wouldn't be mining. Because anyway, you do a lot of work to run all those scripts, right? So the proof of work just becomes, well, no matter what, you have to be mining because you have very little incentive to run a node just to have all that expense of running all the scripts and running all of that for nothing, right? And that's going to be probably more expensive than Bitcoin because you'll have much more contracts, much more alternate applications, on top of which you still have the signing. So you will have very little incentive to run a full node that's not mining. And then you have to wonder, okay, what's going to be the mining algorithm then? You still have to have a proof of work. You still have to prove that it works enough, or more than anybody else in the network can work. So that's also the part that does things to do some work. Then the time to validate a block is still kind of not so clear, right? In Bitcoin, validating a block actually takes a little bit. There's a lot of signatures, and I spend a lot of time optimizing how fast the signature are made. So when you have X unknown scripts to execute before, that's still kind of unknown. And then because of the scripts are generic, you have a pretty high attack surface. Pretty high.
What's the last bullet there?
So if you, the ID is, and that's a security ID, but anyway, if you, like say you have a machine, you have 0 port open, 0 connection to the outside world, then the surface area with which I can attack you from the network is really limited. People have found ways around it, like you can send viruses through the speakers and everything, but that's getting a little harder. Now, if you have a server that has all the ports open, a whole bunch of software that you don't even know what's running on it, very high surface area for attack.
Okay.
So if you transport that to Bitcoin and Ethereum, right? Bitcoin, it's a complicated system, but it's been around for a while. Most of the holes have been plugged. Surface area, maybe medium. And thankfully now there's enough value on it that there's a big holes, somebody would have found it. Ethereum, really high surface area right now, at least. Right? You have scripts that are, well, it can't do technically anything, but that can do much more. That are executed between peers that can also do much more. So much higher attack surface area. That's the. So just to finish, so after all of that, you could think that I will never want to do anything with Ethereum. Actually, it's kind of the opposite. I hope that it will work, and I would really like to implement it as part of a platform and adding it as another currency that you would support. My whole point is that there's still big holes that need to be filled, and I think more people need to be thinking about those or worried about those than saying, oh, let's make a higher level languages that look like Python that we can play with on top of the contract so we can just. And implementing languages is not that hard. There's enough out there to kind of see that. Finding like a good proof of work algorithm that has the right characteristic to do that, the kind of thing that we were just talking about, so that everybody can run a full node and have the right level of incentives for it, it's much harder. Right, that's it for me. That's where you can reach me. Send me an email of insult or something. And that's about it. Any question before I? All right.
Well,
yeah.
Oh yeah, sorry.
Back it up a bit.
Yeah, yeah. Which?
Yeah, there.
This one?
Sure. So the miner reaps the benefits, but because the script is secured by the whole network. Well, with the ghost protocol, I think people that, at least the current mining algorithm, the people that are close to the solution also get a partial reward. Also, one of the incentives for, yeah.
So, sorry.
So all that's not just the miner that gets to be.
So how does that work though? Because if I send money to an agent, a script that starts running, right? Then say there's 100 peers in the network.
Right.
So that means I will have to send enough money to pay 100 peers, right? And if there's 1,000, that means I have to pay 10 times more. It's 10,000 now.
No, the amount that's allocated is split. So the miner.
Split amount, okay.
Yeah, what goes to the, I think it's like 89%, and then the close uncles get 11 or something like that. It's not a full. So the reward isn't all going to one miner. I think under Ghost. I have to look at that. There's why would I run a node? Well, if I want to interact with the network, I probably want the blockchain on my machine.
Oh, wait, yeah, but that's more.
If I want to run a contract, like just as an end user.
Yeah.
That's a reason to even without mining, to run a full node.
That's more a centralization argument, right?
Right.
Okay.
So proof of work. I know people are like really worried about the proof of work. They're trying to figure out a good proof of work that stops decentralization, memory hard, ASIC resistant. But you know, I think there's a little too much worry about that right now. It's designed so they could actually swap the algorithm out and put another one in, although that's notoriously difficult with Bitcoin because there's so many people in it already. But if we have the point where there's like Ethereum ASIC miners being built, I mean, I think that's, you know, hey, we won the first, couple of years, right? So if there's that much interest, the centralization becomes an issue with mining, then that means we've started off pretty well. So I'm not as worried about the proof of work as a lot of the researchers are in the Ethereum team. Like, it's a good problem to have. Hey, too much centralization. Everyone's throwing millions of dollars into mining rigs. I mean, that would be a good thing in my opinion, at least for the first couple of years.
Yeah, the point is how it adds up to the one above, right?
Yeah.
That if you have a proof of work that's quote expensive, that requires ASICs, right? So requires special equipment, then it becomes
centralized.
It becomes
But
centralized.
it's so valuable that people are going to kick $10 million into mining equipment. I mean, obviously.
Yes, but then there's very little incentive for you to run your own full node.
Correct,
right?
correct. But it's one of those good problems to have 3 years from now. I mean, as an altcoin with no one mining, you know, having anybody interested.
Yeah, if you have one
mining,
transaction a day.
Yeah. I mean, normally these coins will just die in the first 6 weeks anyway, right?
Mm-hmm.
So people are chucking ASICs at it. It's because the coins or the platform's fairly successful. I think the time to validate a block is in around a minute.
I think both my understanding with the goal, but
yeah. So, anyway, it's a good talk.
Thank you.
Anybody else have any questions? Any questions for the gurus? I have. Oh, please.
So, how do you see the attack surface area being reduced for Ethereum? Like, what can you guys
I mean, what kind of attacks? Or
you mentioned that the attack surface area is
Yeah.
quite large. How can that be solved for?
well, so you have to reverse the view and say, okay, I have to implement all of that. So I have to implement everything that Ethereum allows. So you have a fairly extensive. So what you have to implement proof of work might be you still have to implement all the peer-to-peer clients. You have to implement a runtime for it, which is going to be the virtual machine to execute all the opcodes and everything. There's a fair amount of them. Then you have to do all the validation for the Ether being spent. You have to relay, validate the transaction before you relay it. It's non-trivial. The chances of a bug finding its way in there is pretty high. The higher surface. So you can run any kind of attack when you have a bug in one of the opcodes that's in there. There was a bug like that about a year and a half into Bitcoin, which had been plugged pretty quickly, but we're still letting people. There was a problem in the validation of the signature, and with the right sequence of signature plus operations before, basically the signature wasn't validated. You can have any number of that. After that, the more complicated the implementation, the more chances for vector of attacks. And you'll have plenty. If there's any value in it, you'll have plenty of people trying it. And then you have other attacks, like Litecoin. They've been attacked really quickly with penny flooding. So people would write these giant transactions with giant number of inputs and outputs, which take a while to validate because ECDS signature validation is like it takes a little bit. And people are just penny flooded, sending very, very small transactions with a lot of number of them, and then the whole network is kind of grinding to a halt. So it's that kind of attack. If there's just an operation that's not value high enough, you can just send it, right? Have a lot of people who work on it. If you have enough control, I don't know, maybe you can find an attack where the reward you get is actually higher than the expense of the network. So it will still cost you some, but a lot of people are stupid and not very good intention, and will just try just for the sake of trying. Like they were saying about Litecoin, right? The guy had nothing to. I mean, you spend some Litecoin to do it, so he had no interest in doing it. Spend some time to do it, but it still was a big problem for Litecoin for several days to actually patch it, increase fees, things like that. So that's my surface area problem. You have a lot of code, it's and complicated implementation that seems to only grow more complicated. And so lots of vectors.
So let's thank Matthieu.
Thank you.